And so our next presenter, he's all ready to go, is Dr. Hank Korth from Lehigh University, professor of computer science and engineering, and the director of blockchain lab of Lehigh's blockchain lab at the Center for Financial Services. His previous work experience includes he was the director of database research at Bell Labs. He was the vice president of Panasonic Technologies and was assistant professor at University of Texas at Austin. Since coming to Lehigh, he spent 7.5 years as the department chair and served as the co-director of the computer science and business department from 2012 to 2020, which just happens to be the program that I graduated from. He is the co-author of the leading database, or one of the leading database textbooks, Database System Concepts, which is currently in its 7th edition. He's a fellow at ACM and IEEE. He is a member of Lehigh's Scalable Systems and Software Research Group, which I was a part of. And he currently focuses on blockchain systems in education. On a personal note, Professor Korth is one of the most intelligent and humble people that I know. And he has an endless list of puns, all sorts of jokes that never gets old. I know that I would not be where I am today without his help. And it is my honor and privilege to introduce him to you all. So thank you for being here, Professor Korth. The floor is yours.
Hey, Jimmy, thank you for all that. That's quite the introduction there. So I put together a who am I slide. Who am I? You've got that already. Let me just roll on here. So what I want to talk to you all about today is, okay, that's kind of overlaying oddly, but good enough. Pop ahead a couple. Okay, we got it. Good. Thanks for hanging in there. So I guess I'm between the shots and pints and happy hours. So that should be fun. So what I wanted to talk about today is, something that's actually been in every talk. We're hiring. Well, from where are you going to hire? And obviously universities are one of the hunting grounds. But the question there is, what should we do? What are we doing? And who are we trying to teach? Well, I mean, obviously, looking at this crowd here, it's, developers, researchers, but I would contend that another important role for universities is blockchain education for all those other folks I list up there. All it takes is a quick look at some of the strange policies coming out of DC to realize that we really need people in government, in enterprise, even broadly among citizenship, who are truly literate on blockchain. But if you look at the developers that are really making a difference these days in blockchain, some of them have gotten there not bothering with the university education, which leads me to my next slide, which is one possible view here is one going back to an album I first listened to when I was about Jimmy's age. Actually, probably still just a tad bit older. And that is, do we really need education at all? And so moving on from that, then, I can ask the question, so what place does a university really have in the blockchain world? Can we really provide the value that we need to for what we charge? And yeah, we charge more than a Bitcoin a year for a residential university. Not cheap. And so next slide, please. What I'd like to do in this is not just tell you, what I'm doing here at Lehigh, what we think we might be doing in the future, but to make this a two-way discussion, a chance for me to hear a bit also about what you all think ought to be done in this space. And so, what we're doing today is far from the final answer. And my email address, it's on the title slide. I listed again. Really love to hear from you, not just in the questions, but also offline afterwards. And so if we go to the next slide, Jimmy, before I talk about the specifics, the issue of what to teach is it's a long story in computer science and a constant battle between the folks focused on that first job. Let's teach today's cool technology, which has been so many different things over the years. And then there's the fundamental, traditional type folks who say, no, you should be teaching basic lasting concepts. Of course, the answer is you need a mix of those, but what's the right mix? What's the collection of concepts, facts versus experience doing things? And then doing what? You see lots of computer science where you see students doing coding, but more just for the sake of doing coding as opposed to really learning how to code, how to develop, how to think. And so we need to find this right balance between the immediate and practical and the basis for a career. And in all that, I mean, listen to lots of folks talking about education, and they forget that it's got to be fun. If you're going to be in a career for some 40, 50 years, and believe me, I know about that, you really need to enjoy it. And so showing the fun of doing all this stuff, and certainly in blockchain, I mean, I can't think of a more fun thing to be in. And that's got to be conveyed in any kind of reasonable education. And so next slide, please. What is blockchain? And if I talk to some of my colleagues, here in computer science, they think, well, it's just one more thing in computer science. But it's a lot more than that. Among all the various applications of computer science, blockchain's unique in its immediate impact on other disciplines. I mean, listen to the talks we heard today and we hear elsewhere in the blockchain world. Finance is always there in so many different ways. Certainly DeFi, central bank digital currencies, and then beyond the finance, things very quickly get to issues of privacy and governance, the whole idea of decentralization. And these are things that go beyond computer science concepts, yet they are immediate and fundamental things in blockchain. And we really then need to train not just computer scientists to do blockchain stuff, but train these finance professionals, policymakers, politicians, yes, even lawyers and journalists, so they avoid making some of the bad policies we've seen coming down the road. And so next, please. There are some real challenges in trying to communicate blockchain technology to students. I think one of the biggest challenges is that it's not just teaching about computing systems, consensus, crypto, etc. But almost any public blockchain has embedded in it an economic ecosystem. The incentives, how people behave, believing that incentives cause people to do the right thing, but then having further punishments when they don't. This is the domain of economics class. And even there, the students who take a couple of courses in economics, they take macro and micro. What they really need probably is game theory. And that's considered a more advanced course. So we face this problem that to teach a blockchain course, we really have to bring in a whole pile of disciplines that we don't teach very well in the university. I mean, even math. What do we make everybody go through 3 calculus courses? Well, I start off with crypto, group theory, discrete mathematics, things that we don't teach. Actually, discrete math, we don't teach in our discrete math course. So it's a really challenging setting, but most definitely, as I've said. So if we could move ahead once again. What I'm going to be doing here is just start off by taking a stab at what we're doing. Not that this is the right thing, the definitive thing. In many ways, it's just the result of an evolution of several years of putting together a larger and larger blockchain program. But what we've got are a bunch of courses, and I'll talk a little bit about each one because I certainly want to get some feedback on what's in those. But then another aspect of what we do, and something I think is very important to that more practical side of education, is capstone projects. So all our computer science majors, we have a whole bunch of different programs, but at the end of it, spring junior year to fall senior year, they do a capstone project. And typically these are done with outside business partners where they are trying to solve a computer science problem in that enterprise. And we put together a bunch of those in the blockchain space. Jimmy's one of those students who did one of those. And so that's one way of getting some nice real world training in the blockchain world. Another is various research projects and independent study projects. And I saw before I started talking here that one of my current master students and also ChainSafe intern, Maxime, he's on here. Hey, hi, Maxime. And then another thing we have is a whole bunch of interdisciplinary collaboration. So outreach beyond the computer science, kind of the tech side of blockchain to folks, particularly in the business side of Lehigh. And so with that, let me move ahead and say a few words about the things we're doing. So in courses, we've got 3 courses now. And okay, so I listed our course numbers. You don't care about that, but the content. So that first one, CSE 242, is unapologetically computer science, an elective for computer science majors. There is nothing on applications, nothing on policy. It's crypto math. So it's cryptography from Caesar cipher to Diffie-Hellman, all packed into a fast-paced, several lectures. Then, cryptographic data structures, Merkle tree and friends. Then a lot of time on consensus. I mean, obviously proof of stake, proof of work, but also a review of the various approaches to message-based consensus. We start with the classic BFT going back to the paper by Lamport, then PBFT on Nancy Lynch's stuff, but then a survey of a number of cryptos chosen not because they're hyped, not because of their market cap, but because they have something interesting in the way they manage consensus. And, so after having obviously covered, Bitcoin and Ethereum, I mean, we talk a bit about Polkadot, Algorand, Mina, Solana, Stellar. Yeah, I got the Stellar cap here. And, and a few others, in each case chosen not to cover all the details, but here's the key consensus tool. The idea being, if you're building a new blockchain de novo, how are you going to do consensus? You can copy something else, or you can look at the key techniques, the key algorithms, and the goals of showing that how do you show a consensus system is correct? So we talk about the formal foundations that come out of the distributed computing community, proofs of safety and liveness, and tie all of that in. And then, of course, there's coding. And there's a project writing smart contract in Solidity. And we have our own private proof of authority node for that, so we don't have to tangle with the testnet. And I can give them as much ETH as they want. We have students who love showing MetaMask and showing they have 1,000 ETH and making their friends think they're rich. But some have joked about trying to sell our private LU ETH, and I sure hope they don't do that. They'll get me in trouble. But that's the CS course. Then the next one, CSB, that's in computer science and business, 242. That's a course that has sort of just the minimum tech, body honest. And then after that, we talk about various applications, policy, and I bring in various outsiders, have a fun group of outsiders come in to talk. I've had the global CTO from Deloitte for blockchain. I've had folks from Citibank, Ethereum Classic Labs. Of course, I bring in my 2 students from the class of 2018 who run the Dolomite Decentralized Exchange, and they get to talk about their experience, and a whole bunch of others. We have a whole bunch of good friends and alums, and among our Lehigh alums is Kevin Worth, CEO of CoinDesk, and pre-COVID, he actually would drive out from New York, come to our class, and it was quite fun for students to get to see him. And then another course we're doing, I'm doing this one for the first time this fall. Lehigh has a Master of Science degree in financial engineering. And financial engineering had been mainly data analytics. The business dean realized that ought to be blockchain too. So I was asked to put together a course for them, and I'm doing that, taking advantage of their math background with financial system on this. You ought to know what it's about. But then a lot of time on financial applications, digital currencies, and policy issues, but a much deeper dive because these are actually finance students. And I'm quite amused teaching that course, I gotta tell you very honestly. So it's financial engineering. I was a math major, have a degree in CS. I've never taken an engineering degree. I've never taken a finance course, so no engineering course, no finance course, and I'm teaching a grad course in financial engineering. Perfect. Anyway, let's go with the right side of things here. Moving away from the teaching space, comments about things we're doing in research. And we have a bunch of research projects going on here. I don't need to read them to you. You know, all the acronyms and buzzwords clearly, familiar to most everyone here. But we're also working in a synergistic way with our colleagues here. So I'm part of a broader research lab that's focused on parallel and distributed computing. We go by the name Scalable Systems and Software Research Group. And working with folks there and with Maxime, who's listening now, we're looking at how to take advantage of modern computer architectures to speed up the generation of zero knowledge proofs. You know, cool stuff and part of the synergy you can get in a university setting. In terms of synergies with business, I'm working with a professor at finance on issues in central bank digital currency policy, and working with some students looking at something that's kind of bridging in between those things, looking at how one could architect a governance mechanism to minimize the opportunities for various MEV exploits. And if they can't be avoided totally, make it possible to detect them, even after the fact, either as part of validation or in a more, government-driven thing like a CBDC for regulatory purposes. And the last thing I list here on data consistency. So this one goes way back. Yeah, I told you I was old when I quoted Pink Floyd, but back in my earlier days of doing database research when I was at the University of Texas, we looked at the idea of database consistency across independently managed databases. Well, if you look at it slightly differently, think about consistency across independently managed chains, parachains, shards. Very similar issue, but some of the details, of course, are quite different. And so we're looking to bring some of our old-time database expertise into the blockchain realm. And then, Jimmy, if I can have the next slide, I'll say a bit about our undergraduate projects. We have lots of undergraduates doing capstone projects, have a couple of completed ones, one involving verifiable letters of reference, and some of the participants in that are on this call here. We also did a project to look to replace the on-campus currency. You may know most universities have some kind of dining dollars type thing. It's called Gold Plus at Lehigh. So we did a project to replace that with a cryptocurrency. Lehigh is the Mountain Hawk, so we called it Hawkcoin. And we almost got it deployed. We outperformed their legacy system, but the university quickly went to their outside vendor and got a performance upgrade, because I think they didn't want to bring in our blockchain system and maintain it internally after the students graduated. But it was fun anyway. And looking forward to the spring term, we are lining up a whole bunch of cool blockchain projects. I haven't finalized all of them yet. January still, a month and a bit off, but we are looking to have a couple of enterprise blockchain projects with a major database vendor working with Fabric. We're looking at working with a couple of blockchain development firms with some interesting projects there, possibly one in health, and then one that's a really cool social justice theme of using the blockchain to verify that farm workers get paid. The specific one in mind here is going to be Bitcoin. And so the idea then is that various fair trade organizations can look and see, hey, yeah, the workers really got paid. And with that, then hopefully, help ensure not only that they do get paid, but then that their produce is then marketable, creating the whole, virtual cycle there to, or virtuous cycle. I keep saying virtuous because I'm too computery, to create a nice financial ecosystem there. And then moving ahead again, Jimmy. I missed something on the previous one. Sorry, my bad. One off here because I missed the undergrad independent projects and listed a couple that are going on now. I've got 8 students working with me in the spring on various independent projects. We're defining, a number of these are fun educational things for the students. Some are things that could certainly turn into research projects for students who stay on for a master's. And now to the next one, Jimmy. So I talked already about the fact that I'm working with folks in finance, that we've got courses there. And in the Center for Financial Services, they set up a blockchain lab. And I'm the blockchain guy, so I get to run that too. And on the business side, and trying to practice what I preach in terms of outreach, I've run a seminar series for business faculty, basically going through every discipline in our business college and letting them know that blockchain matters. Yes, it should be in your courses and certainly should be on your radar for research. And then moving ahead once again, Jimmy, that's where we are now at Lehigh. And as I said, this is just, a stab of, what to do in this space. Not the final word, looking for feedback. And I mean, the bigger question here is, are we really doing things to provide true value to students and move them into a constructive, fun career in the blockchain world? Or are we just another brick in the wall? And so I'll go ahead and take whatever questions there might be. And thanks for hanging in there this long.
Just a second here to come back on.
Yeah.
Okay, here I am.
Okay,
awesome.
now I'm set up to see the Q&A myself as well. And I love this one. I see Pink Floyd sent in a question. Education is largely outdated. So how do we endeavor to keep the curriculum up? One of the things that I talked about is this trade-off between current technologies and concepts. And if you look at all my courses, there's one biggie missing, and that is a deep dive into the tools you need to use to code today in the blockchain space. And that's something we make up for with the independent projects, the capstones, and so on. And so that's the part that's current. The course stuff is more focused on the lasting. But more broadly in computer science, we have that problem big time. And we try to revise our courses, but of course you've got faculty who are focused on the research. It's a lesser priority, and it is a constant running battle. And then we have, shall we say, external enemies. Basic choice of programming language. Okay, we do Java. Please don't cringe. Why do we do Java? Well, the AP exam is in Java. And so unless we want to run 2 paths in, AP students and our own students, we're kind of constrained for making a more modern choice. So constant battle. We try. Jimmy's been through it. He can tell you whether we do a good job or not a whole lot better than I can. So I'll throw the question back to Jimmy.
Gosh, it's coming back to me.
Okay, you can take the fifth on this one.
Yeah,
But I can't take your degree back.
No, that's mine now. I like
Okay,
to
we
think
can let
that I
that
earned
one. We'll take you off the hook there.
it. So yeah, we got a bunch of questions. Yeah. Go ahead.
Oh, good. So I'll move on down here. How do you bridge conversation concepts with individuals who don't have the prerequisite knowledge? Oh, yeah. I mean, there are lots of those, and that's a big problem. It wasn't too long ago, I was listening to some on Sirius XM, some business station, and somebody was asking, which is better, Bitcoin or blockchain? I'm like, oh, I'm ready to just drive off the road into a Merkle tree or something. It is really hard to communicate this stuff because it is so different from most people's experience. And then you have folks like Mark Cuban and Elon Musk who seem to make things worse rather than better in a whole bunch of cases. But I mean, that's something in my more business-oriented undergraduate course. That's kind of the first thing I have them do. First paper they write, explain Bitcoin to your grandmother. And just to get students to think about how you take these ideas and relate them to everyday experience. And I've gotten some really amazing ones back, approaches I wouldn't have thought of myself. So I think my short answer to that question as a professor is listen to your students. Okay, so multidisciplinary bridges. I mentioned the bridges with finance. We've got quite a bit of that there. There's a professor in accounting I talked to who is very computing astute, and actually one of the independent study projects I'm planning to do this spring likely will involve him and looking at various issues of validating and presenting business data using ZK technology, so you can hide the raw data but still have in effect an audit. And approach to teaching changed over time. Well, we don't actually have a formal course in Web3. I mean, that's the stuff that gets taught hands-on in the capstone courses or in independent projects. So we're not actually teaching that. We have a web apps course. The web apps course is very Web 2, for better or for worse, but tools you definitely need to move into this space. And if I can ever get in place a true hardcore developer course, that's when I'll get to address your question, but do love the question. And MOOCs would be a wonderful thing. I mean, we obviously have a lot of video in the bank now, thanks to COVID. And I've been trying to run more of my classes flipped classroom style, so the recordings of lecture are the assignment, and then we can just discuss in class. Now, going the MOOC route, love to do it, but I have to get the university to be willing to invest in professional production. As I've learned during COVID, being the presenter, the producer, and the guy watching the chat going on the side, especially when you have something like the Uniswap airdrop happening in the middle of class, as some people will remember, makes for an experience. Yes, I expected a commission. I never got it. Doing something that's truly MOOC-like and professional is a next step, and I'd really like to sell my university on doing this. Chuck E. Cheese as a way to explain how I love this one. This is too good. Is using a Chuck E. Cheese coins, tickets, prizes a good way to explain ERC 20 versus ERC 721 to older students? That is phenomenal. I never thought of that one, but now I could never forget it. Thanks. And then is it difficult to entice students to take a post-secondary program? That's something that is a broader thing, just in terms of, high school students going to college. And if they don't, I don't get to see them here. When I was running our Lehigh Unique Computer Science and Business program, which is a single degree, dually accredited, both CS and business, worked a lot with admissions. Yeah, we got a graduate there. And so I got to, high school students who at least go to a college info session are already with one foot in the door. But I really tried to, sell the value add. And I think the value add is really the broad immersion you get, not just so much necessarily even in courses, but from your fellow students, that you hang out with students majoring in so many different things, thinking about things in different ways, that I really view, the 4 years in college as learning to think, and with some focus. And a hard thing to do, and some universities are trying to go in many ways in an opposite direction there. And that comes back again to this whole idea of blockchain and its connectedness with the real world. In these policy and application-oriented classes, I deal with students with a broad range of political viewpoints. Students just off the plane from China who love DCEP, the Chinese digital currency, and students who are very much hardcore libertarian. And I need to challenge them both and try not to reveal my views, because that's not my job as an instructor. Yeah, some of my students probably know what I think about things, but that's for another time and place. And how do I work with finance people? The short answer, very carefully. Yes, token economics. Well, I mean, I think, case in point here with a colleague of mine in finance, Kathleen Hanley, we've been putting together like a little proposed policy paper on digital currency. We were working with a group trying to put together things for the then new administration. They didn't speed us up, they slowed us down, but we've really got a good, give and take going on there. Now, on the other hand, when she came to guest lecture in my class, and I said, well, in the last class, all of the students created their own ERC20 token, she was ready to pull out her cell phone and call her former colleagues in the SEC and put us all in striped pajamas, until I added on the test net. So, yeah, I mean, once you establish, a good rapport, and they realize I'm not really, a anarchist, I actually understand what they're doing, and that they also understand that the blockchain world is coming into their world, whether they like it or not, and might be a whole lot better if they understand it. Then we can start to explain things that are going on, and to realize, that, if we talk about a blockchain-based digital currency, well, there are other digital currencies out there. They're not on a blockchain, but, airline miles. That's a digital currency. It's private. And, so there's a continuum of choices, and we can create a degree of comfort in that way. And, okay, the whole idea of anonymity, money laundering, and so forth. Yes, I mean, that's the other thing. Are we just simply promoting money laundering here? And I mean, we certainly talk about the fact that, Bitcoin isn't really anonymous. You can, with a little bit of work, figure out who's probably behind a whole bunch of the various IDs, and point out that, the best way to money launder is the US dollar. We're not talking about banning that, as far as I know. And so we really need to think here about the broader infrastructure of finance, appropriate regulation, not over-regulation, and that this could actually be a more effective means to do that. And I've had lots of debates with students on those kinds of things. And Jimmy, did I miss any of the questions rolling through here?
No, I think you got them all, and I can't think of a better place to end it. Great job. I love that you went to town on the questions. Easy. Oh, I think it's fine. There's another one that popped up.
Oh, is there? Oh, here we go.
What are your top 3 real life applications of blockchain?
Oh,
if you have.
Well,
verifiable reference letters, right?
Oh yeah. Obviously, Jimmy's project in Hawkeye. No, I mean, obviously, real life application of blockchain. I got to go with Corey and Adams, decentralized exchange Dolomite. Real proud of those 2 students. They were in my first blockchain course. They were sitting there, not paying any attention and just coding away. And I didn't care because I knew they were doing good things. And so I mean, I'm really proud of the students we have who are out in the blockchain world making a difference. Those here, I've got a student with an offer from Coinbase. I got the students doing the decentralized exchange, some other students coming out with some really nice offers, but they're still figuring out what they're going to do. So I think in some ways, my personal favorite application of blockchain is helping to bring out the students who make blockchain and make it better.
I, as one of those students, can think of no better way to end the questions. Okay. That was amazing. Great presentation.
Hey, thanks for having me here. It's been fun. And again, I want more feedback. hfk2@lehigh.edu. I'd love to hear from you.
Yes, please reach out to him. And thank you so much, Professor.